Hi all, this is Mr. Yeager with Physical Science. In this hopefully short video, I am just going to look over isotopes. So the last video, hopefully it was watched, was about atoms and the structure of the atoms and everything. So now we're looking at isotopes, a special situation that occurs with atoms of the same element. So you can already see there, this is the definition of isotopes. The atoms of the same element, but different number of neutrons, okay? Atoms that have the same element, sorry, already drawing all over this, but different number of neutrons, okay? What that means is, let's go right off the bat. The atoms are of the same element. Change my color, okay? Which means, if they're of the same element, they have the same atomic number. Which means they have the same number of protons. Okay? I'll write out the word protons so we can see that. Protons. Okay? The atomic number, the number of protons. But an isotope of that atom, okay, would have a different number of neutrons, which means the mass number of isotopes are the same. So we're going to see that we have multiple amounts of the same element, but even amongst those, they're not all perfectly the same. All right? Some of them have slightly different number of neutrons or mass number within their nucleus, since that's where they're found. The protons and electrons will stay the same. So, I have examples of basically isotopes right here. We have carbon-12, carbon-13, carbon-14. I'm sorry, that's kind of a little bit small, but that's okay. All right? Again, you can see the way I have it written, carbon-12. What does that mean? The 12 is the mass number. So what I'm showing you here is all of these elements are carbon, but they have different mass numbers. So what's the difference? Not the protons. Not the protons. Okay? The protons are all the same because otherwise the element would not be the same. Carbon has 6 protons regardless of how it's organized. It has 6 protons. All right? But the number of neutrons is what's different. So you can see for carbon-12, 12 minus 6 is 6 neutrons. Carbon-13, 13 minus 6 is 7 neutrons. Carbon-14, 14 minus 6 is 8 neutrons. So each of these has more neutrons in the nucleus if the isotope number is going up. There could be ones where the isotope number goes down. All right, it's just the way it is. Just what's involved with it. Okay. That's basically it. Again, electrons we don't worry about because electrons is equal to protons. So if I had to figure out basically the number of protons and neutrons in these 3 isotopes, people make mistakes on it all the time, so we got to be careful. I always tell everybody, fill out the proton column first, or the proton row, whichever way it's set up. Since all of these are the same element, and I would look it up on the periodic table, it's hydrogen. I would look up on hydrogen, I'll draw it over here again. Okay, this is what we would see on the periodic table in one of the blocks for hydrogen. I would pay attention to the top number and go, what does that mean? That's the atomic number, that's the number of protons. Well, if they're all hydrogen, they all have to have the same number of protons, which in this case is 1, 1, 1. They all have 1 proton. That column has to stay the same in any isotope problem. Okay? Proton stays the same. But what's different is the mass numbers, which means there's different number of neutrons. So how can I figure this out? I can basically just subtract that number. Okay? Or I could say 1 plus what is 1? 0. 1 plus what is 2? 1. 1 plus 1 is 2. 3 minus 1 is 2. Now again, some people get confused by that because they're like, wait, 2, 1, what? Guys, all I did was protons plus neutrons equals a mass number. So 1 plus 0 is 1. 1 plus 1 is 2. 1 plus 2 is 3. Okay? So that's all we're basically working with there. Now, another possible question that can come up, and this is where atomic mass might actually be used. One of the few things that could be used. Okay? The atomic mass, as I said, is an average of all of the isotopes. It ends up being what's called a weighted average. All right? It's the same way that almost all schools do their grades, where your tests count more than your homeworks, your quizzes, your labs, etc. That's a weighted average. What this weighted average is telling you is which isotope is the greatest. Which isotope are there the most of? And so what you do is if I give you a list of isotopes and you look at the atomic mass, whichever number, 1, 2, or 3, is closest to this number, 1.008, that means it's the most common of the isotopes. All right? So the isotope number closest to the atomic mass is the most common isotope. Or sometimes they use the word abundant. Okay? So, for example, if you had a question where I'll go back to calcium, that was used last time, where the atomic number is 40.08, and I said there's calcium 38, there's calcium 40, there's calcium 42, there's calcium 43. And that was your choices on a multiple choice. Which of these is the most abundant? Well, 40.08 is pretty stinking close to 40, so I'm assuming it's that, and you are correct. Okay? Now again, that's not always perfectly true, but I'll tell you on your EOC that will be true. Okay? If you get into a higher level chemistry course, you'll see that sometimes those averages aren't perfect at predicting. But I would say they're easily probably almost like 2/3 correct. Okay? So, just wanted to point that out. I think that might be it. Yep. So that's the end of that video. So again, just what are isotopes? Isotopes are the atom of the same element, but different number of neutrons, different mass number. Okay? Thank you.